Here is an angle of elevation problem here, but this one's a little bit more involved than the ones we've done so far. So I'm just going to read it for you. Marla needs to find the height of a building. From a given point on the ground, she finds that the angle of elevation to the top of the building is 74.2 degrees. She then walks back 35 feet. From the second point, the angle of elevation is 51.8 degrees. Find the height of the building.
We're about to have two triangles.
Yes, we are going to have two triangles. So, I need to draw a couple of things. I always like to start with the ground. So I have a starting point. I have some building that she's going to try and find the height of. So here's my building. Okay, and then I have Marla. Marla, I'll put her here. From a given point on the ground. So this is from the ground up to the top. So they're not using her eyeball. They're using the ground. So from the ground up to the top of the building, at this first point, she finds that the angle of elevation is 74.2. Okay? So from the ground up to the top of the building, 74.2 degree angle of elevation.
Yeah.
Now,
She walks back.
Marla is going to walk back 35 feet. So now she's going to be over here. I know that this distance is 35 feet. She does the same thing. Now, from a spot on the ground up to the top of the building. Now she measures the angle of elevation to be 51.8. I'm looking for the height of the building. Okay? So, I'll call that H. That's my ultimate goal, to find the height of the building. Yes, I have basically two right triangles. I have the smaller one here, and then this longer one here. But that's all the information I'm given, and I'm supposed to be able to find H.
You can find the angles of the second angle in the 74 minus 1, or 180 minus 74. That's bad, dude.
You can.
You get that angle. Something else from there. And something else from that. And then you're at your answer.
Well, so you're saying find these angles?
No.
Oh,
I'd find the first Martha, like where she's standing.
okay.
I'd do 180 minus 74.
Oh, to find this angle?
Yeah.
How will that help you?
Because we can.
No, you just alter it, so you just copy it.
This angle, well, I mean, maybe there's a way to find it using this angle. I don't know it.
Who knows?
Maybe. I mean, you could go down that road and maybe something makes sense.
Supplementary.
I love supplementary angles.
Let's just look at the small triangle, okay? Is there anything else that I can find on the small triangle? I have this angle. I'm trying to find this height. If I had one other piece of the triangle, not the other angle, but if I had one of the sides, I don't have any of the sides, right? I have nothing. But if I had one of them, I could very easily find H, and it'd be no big deal, right?
That it would be the bottom.
Well, okay, let's put an X here. I don't know this, but if I did know this, then I could find H easily, right?
But don't you know that the third angle already?
But a third angle is not going to help me get a side. I need at least one side to get any of the other sides.
Don't you, if you had the other angle, you could do like the second side and get you, oh, that's, dang it, that's what
Yeah, yeah.
No solution.
Well,
Undefined.
here, so now I have two variables. So I can solve for two variables. All I need is,
Two equations.
yes. I bet there's a reason why there's two triangles.
Oh, that's
Oh, we got a system.
That's it.
We're just in algebra.
No. let's just see. Now, let's look at the small triangle, okay? Give me an equation. It's okay that's going to have two variables. Give me an equation that relates these pieces.
X squared plus h squared equals c squared.
Well, that's a new piece that I don't need. You don't want to introduce a third variable. We don't want that. I have three pieces right here.
I'd probably go with tangent.
Yes,
Yeah.
tangent. Tangent of this angle would equal this over this, opposite over adjacent, right? Okay, so there's one equation. It will. Tangent of 74.2 degrees equals the opposite side, h, over the adjacent side, which is x. Okay, so there's my first equation for the little triangle. And I bet if I can kind of try the same thing with the big triangle, using only the same two variables, x and h, if I only have two variables, I should be able to solve with two equations. So, can you write an equation for the big triangle?
35
Tangent of 51.8
Equals x plus 35.
no equals 8 plus
h over,
That's what I
35
meant.
plus x.
yes, this whole side would be 35 plus x.
Oh my god.
Wait, but that's not a right triangle.
This triangle you're looking at.
Oh.
So that's why this whole side would be 35 plus x. Yeah. So, two variables, two equations. I should be able to solve this. It looks worse than it is, right? Do you remember one way to solve a system was substitution?
Elimination
We have to do
was
that.
Mm-hmm.
another way. Or graphic.
Right, look at you go. The easiest way here is going to be substitution. So all you have to do is get one variable alone.
I forgot.
Well, it looks pretty easy to get one of these variables alone.
I'd
And
probably say it's pretty easy to
Isolate
get
h.
yeah, I'd get h by itself. To get h by itself in this one, what would I do? Multiply both sides by x, right? So x times the tangent of 74.2 equals h, right? All I did was multiply both sides by x, and now I have h all by itself. It's actually going to be easier. Instead of taking this now and substituting it in over here, I'm going to save you a little bit of work. It's going to be easier if I get h by itself here too, and then I just set those two pieces equal to each other. So how would I get h by itself over here? Yeah, same idea. I'm going to multiply both sides by 35 plus x. So I'll have 35 plus x times tangent of 51.8 equal to h. Since these two things are now both equal to h, can I just set these two things equal to each other? You sure can. So x times the tangent of 74.2 is now equal to 35 plus x times the tangent of 51.8. You now have an equation with just one variable. So you can now solve for x. I don't know how good your algebra skills are anymore.
solid.
Yeah.
You had me for algebra. You know exactly how to do it.
Well, remember, guys, when you see like this, tangent is 74.2, that's just a decimal, right? That's just some decimal times x.
So it'd be that decimal in front of x.
You could do it, yeah, if you wanted. So you could put it in front. It's not.
Would you subtract and add the tangents? So like, you know, bring tangent of 51.8 to the other side, and you have tangent of like 20 whatever.
You could divide. Here's your first problem, though. You have x's on both sides, right? We want to get the x's together on one side of the equation.
Be 0.
Well, that's not really 1x because it's being multiplied by that. Here's what I would do first if I were you. I would distribute this into that.
Oh yeah.
Yeah. So this side, and by the way, if you like it better to write it as tangent 74.2 times x, because that's really just some decimal, right? So all I did was swap those two. If you like it better that way, it doesn't matter. It's the same math. And I'm going to distribute this in. Excuse me. So one side I'm going to have 35 times tangent 51.8 plus, and now I'll have tangent 51.8 times x.
Oh my goodness.
So all I did was distribute so far.
So now we gotta do tangent 74.2x divided by tangent 51.8x.
What?
Tangent 74.2x divided by tangent 51.8x.
But why would you divide by that? You're not multiplying by it. Aren't you? Yeah.
Oh, add. No.
I would.
Subtract.
Yeah, subtract this to the other side. So I'm going to minus tangent 51.8 from both sides. Now at least I have the x's on the same side. We're almost there. I have both the x's on the left-hand side. That's good. So now what can I do with them?
Divide.
Well, get the decimal there. Be easy, wouldn't
You can just divide the
You
whole thing.
can.
it? And just round it to like the percent.
You can. The problem is that you're rounding a little bit too early. You know what I mean? So like when you turn these into decimals, you're rounding. And so we're trying not to round until the very end. Yeah.
You can put that whole thing into a calculator if you just did tan 74.2x minus that. And then
That's what he was saying. He was saying turn these into a decimal and then you can combine them.
Yeah, no,
Because like,
Zach is saying you divide it, do it at the same time, and just finish the problem.
Yeah. Like do that. Just type that whole thing in, just how it is.
but what? But you.
Divide that
But
whole
those are
thing by 35.
It wouldn't be incorrect because x.
Right, you don't know what x is yet. But there is something I can do with these x's now that they're on the same side.
This is terrible.
Don't put this on YouTube.
X squared.
Don't put this on YouTube. My name is. I'm not. This.
I know someone knows what to do here. We're right here. We're so close. All you have to do, if these both have an x, can't I just... You're close, but...
Divide, multiply, add them up.
Oh, factor.
Yes, factor out an x. So now I have x times tangent of 74.2 minus tangent of 51.8. Oops.
I've written tangent way too many times.
Equals 35 times tangent of 51.8. Now you're right there to get x by itself. Now I would just...
Could you do 74.2 minus 51.8 to get the tangent of whatever output that is? That'll be cool.
No, because then it would give you the tangent of the difference. And
Tangent isn't a variable. It's just like a.
but I'm so... to get x by itself now, all you gotta do is...
Divide.
Yeah, divide both sides by that difference.
Oh,
Then, on the right-hand side, it's a bit messy, but that's why we have calculators. The calculator will do all that calculation for you. And now you have x by itself. I'm a little bit short on paper, so I'm going to run onto this one. But you're just going to divide both sides by tangent 74.2 minus tangent 51.8
I'll tell you.
on both sides. And that gets us x by itself. And if we type it in correctly, we should get a reasonable answer. Be careful. When you type this in, make sure you put, if you're going to do it all in one shot, you got to put parentheses around your entire numerator. So I'll show you how I'm typing it in. I don't know if we can get it both at the same time. Yes, we can. Look at that. So parenthesis 35 times the tangent of 51.8. Close the parenthesis for tangent and then close the parenthesis for that's my numerator. Divided by parenthesis, everything in the denominator will go in that parenthesis. Tangent 74.2, close for tangent, minus tangent 51.8. Close for tangent, close for denominator. There's everything all at once in there. Hit enter.
That calculator is so much smarter.
Did you guys get what I got? And now,
19.7.
Question, are we still doing the building problem?
yes, which we're actually not done yet because X wasn't the height of the building.
What is it? Oh.
But we're right there. So now that you know the X, would you guys say 19.7?
Yeah.
Okay. Now
Wouldn't
I,
that be more rounding than this one?
well, I mean, you can leave it in there if you want. So if you want to go back to now that I have what X is, right? Because look at, how would I get H? Wouldn't I just do tangent of 74.2 times whatever X is? So you can leave X right on your screen. There's X, that crazy decimal. And I just multiply it by the tangent of 74.2. There's the height of my building.
69.5.
I think, aren't you going 2 digits?
No.
But there was 35 feet.
Oh,
So then it's just 69.
Yeah.
That's technically.
Once you're round.
Okay, so just to be clear for the people watching at home, we found X. X, however, is not what I'm looking for. I'm looking for the height of the building. But once I have X, I can find H very easily. We just took this equation, since X was 19.7, multiplied those two together, and that gets me what H is. So my final answer, the height of the building, is approximately 69, what are we, feet? Or, yeah, feet. So there is basically on your one of your projects that we do next week, you're going to do the same idea. We're going to measure the height of something really tall that we normally wouldn't be able to know the height of, and we're going to find it using this method. So I'm going to show you how to measure the angle of elevation, and then you're going to walk back a known amount of feet, find the angle of elevation again. So it's the same exact problem, but it's going to be different numbers, obviously, because well, probably be a little chilly, but we may leave the classroom.
It's gonna be in the 40s next week, I'd say.
What are we doing?
Yeah, I actually heard
We
Monday.
might go outside.
Maybe. We'll see. So, but this is the idea. So, when you come to me with this whole diagram and you're like, I have no idea where to go, I'm going to say, okay, well, show me this problem that you did out. Because everyone will have this in their notes, right? And I'll say to you, I'll be like, okay, well, let's go piece by piece. You can really model. You're doing the exact same work. It's just going to be different numbers.
Same thing I have written down in my
Yeah,
notes.
that's true.
So, that will be next week.